Last time, we explored chain of thought prompting. Now, discover how self-consistency prompting with Llama and Langchain boosts answer reliability. Last time, we used chain of thought prompting to help our language model solve logic puzzles step by step. Now, we're leveling up with self-consistency prompting, running the same puzzle multiple times, then letting the majority answer win. This makes our model's reasoning way more reliable, especially for tricky math and logic. Let's import the tools we need: collections for counting answers, Llama LLM for our language model, prompt template to build prompts, and runnable sequence to chain everything together. Here's our logic puzzle. We're saving it as a variable called puzzle so we can use it in our prompt. The puzzle asks, if 2 hens lay 4 eggs in 2 days, how many eggs do 5 hens lay in 3 days? Classic math riddle. Now we're setting up a prompt template. This lets us reuse the same question format, but swap in different puzzles if we want. We're telling the model to solve the puzzle step by step and explain its reasoning before giving the final answer. This is the heart of chain of thought prompting. We drop in our puzzle right here so the model knows exactly what to solve. And we nudge the model to think step by step. This helps it break down the problem instead of just guessing. Let's fire up our language model. We're using Llama 3.2 with a high temperature setting. That means the model will try different reasoning paths each time. Now we chain our prompt and model together. This makes it easy to run the whole process with one command. Here's a helper function to grab the final answer from the model's response. We'll use this to tally up results later. We're importing regular expressions, or re, to help us find numbers in the model's answer. This line grabs all the numbers from the response and returns the last one. If there's no number, it just gives us a question mark. Now for the magic, we run the chain 5 times each time with the same puzzle. We print each sample output and collect the final answers in a list. Let's count up how many times each answer appears, using a counter from collections. This helps us see which answer is most popular. We print out the tally so you can see how often each answer came up. This is our self-consistency check in action. Now we grab the most common answer from our counter. This is the answer that got the most votes from the model. And finally, we print the self-consistent answer, along with how many times it was chosen. Let's run the code and see if the model agrees with itself. Thanks for watching. Please hit the like button and don't forget to subscribe my channel.